My presentation is, we can say this has been an Estonian real intervention study to have this renovation grant system, KredEx system, which has been now run already for quite many years. And as you know, in Estonia, 65% of the population is living in apartment buildings. It's not like in Central Europe where it's only maybe 40% is typical, but here it is more. And 95% of these apartment buildings are in private ownership. So in modern technical terms speaking, these buildings are not insulated, they are not ventilated, so the technical condition is not very good. But they are mostly built from concrete, so the structural quality is quite okay. This is not a problem. And when you take a look how much energy these buildings are using, so it's typical around 180 space heating, domestic hot water, which is typically district heat, and then some 30 kilowatt hours electricity as well. And this primary energy is calculated with primary energy factors when you will see that the energy performance certificate class, it's typically F or G, so it's not good at all from that point of view. And in our energy performance certificate scale, G and F, these are almost the second last classes, which represent the current state. And then in this renovation grant system, to get 40% direct financial support, 40% from total renovation budget. Indeed, it's a large amount of money for the house associations, but the requirements are also very strict. So you need to improve to class C, which is right now minimum energy performance requirement for new buildings. So then you will get the 40%, and this is in the new system. So the first period from 2010 to 2014, when the maximum was 35%, but basically the same requirement. And there are also 25 and 15% grants available. So this is large amount of money for housing association, and therefore there are very detailed technical requirements to get that money. So the process starts so that this housing association, they need to make a decision. We will go to have such a deep integrated renovation, and they need a simple majority for that. Just one general assembly meeting and to decide it. Then they need to hire a qualified technical consultant who will start to steer or the preparation process. And the preparation process for the application is very comprehensive one. They will need to order all technical design, so it's a full set of design documents, what needs to be done before you can go and apply. So, and it also includes calculated energy performance certificate to show that you are compliant with these technical requirements. Then they will need to apply for a building permit, and it basically needs to be issued to them. And they also need to get the credit decision from the bank. And then you can walk to the KredEx and submit your application. And it's indeed a lot of work before this can be done, but the system is so that if you fulfill all the requirements the KredEx system has, then you will receive this funding. There is no, KredEx cannot say no if everything is okay. At least so far they have this funding available. And when application is submitted, the process in the KredEx will include investigation by the third-party experts, so that the design documentation, everything has been solved, everything is taken into account, and quality is okay. And if not, then applicant will need to revise it and submit it once again. And when everything is okay, then they will receive a funding decision and can go to a tendering process and to construction and so on. There are some new things. KredEx will require the commissioning protocols for the ventilation rates, for example, and grant payment will be after handing over. And then it is also required to have an energy performance certificate after 1 year of operation. So it's quite a comprehensive system. It was not so complicated when it was started, 2010. It was a bit easier one with old system. And with this system, close to 700 buildings were deeply renovated. So the total number is about 20,000 apartment buildings in Estonia, so it's still long work to do. But the first 700 have been done, and now the new system is running, so it's close to 1,000 buildings which are already renovated. Within 20-30 years, it's basically possible to renovate all of the buildings which will want to go to the renovation process. And this 35% grant at that time already was the most popular one. Average savings quite good, but there were also some specific problems. This is one of these good examples done with this old system. 2 million euros investment, close to 200 euros per square meter, from which renovation grant 35%, and around 60% heating energy savings. So it's not bad. And in this building, you can really see that all this external insulation was installed to the facades. New roof was built indeed with new insulation, new triple windows, also moved to the insulation layer, which is important to avoid thermal breaches. And heating system consisted installation of exhaust air heat pump, and the district heating system was kept in use as well. And the ventilation was solved with installation of ventilation radiators, and old stacks were utilized for the extract system. So it's a kind of mechanical extract ventilation system, but air is preheated in such and filtered in such ventilation radiators. So indoor climate should be very good after such a renovation. So this is example how it was running before. And before I will go to this period, what is running right now, I think there are a couple of aspects which are wider when we speak about the renovation. Indeed, this economic aspect is the most important, because if you like to demolish and make a comparison, in these cases it's 200 euros per square meter, maybe 300 euros. And in the case of demolition and new build, it will be 1,300 euros per square meter. So it's a huge economic difference. And at the end, it will be a new concrete building, so walls are maybe a bit more straight, but apartments are as small as in these buildings, because that's a common practice today. So what's the quality improvement? Indeed, it's some quality improvement, but there is no economic sense in such a process if it is possible to renovate these buildings. And we have had a study which has quantified that from the renovation, tax return for the government is as much as 32%. So from total renovation budget, 32% is coming to the government budget. And indeed, aspect of creating new jobs is important. €1 million renovation project will create 18 jobs. This is also not bad. And basically to get such a system working, it's important that there are some inputs by the government, so giving these renovation grants together with very strict specification, well-detailed renovation grant system, when the private sector will start to invest. So private sector will need to invest 60% in this case, so renovation grant is typically 40%. And then there will be direct effects, which we really know, how much is a tax return, how much is a job creation, how much are the energy savings, and also we know how much is the real estate value increased after the renovation. And after that, there are something we know that we do not know exactly, as these macroeconomic effects, which we have not analyzed. These are a bit too complicated for just typical engineering calculations when you need to have some economic scientists to do this kind of analysis. But at the end, it will be more or less, it will be budget neutral activity or even a positive result for the government if these macroeconomic effects will be taken into account. So to be more specific about the cost structure of the renovation projects, typically it's around 50% is a material cost. Labor cost 34% in average, and project management cost is also quite a significant, 12%. And when the tax return is, it will form from value-added tax, around half, and the labor tax will be another half, and this will come from consultancy. Indeed, is a small part, but something, and construction is the most significant, but also manufacturing of the construction and building installation products is also has some significance. So these effects have been quantified, and it's that's the reason the government can put such a large amount of money for the renovation projects. So another aspect is the energy use in the buildings. So we know that the building stock will use a huge amount of energy. In Estonian case, it's actually 50% of the final energy use. In European scale, average is 40%, so in Estonia it's even a bit higher. But there is a lot of saving potential. And this saving potential has been also quantified, can be done with scenario calculations. And this example shows a calculation for next 20 years, and it is done with slightly different renovation rates in 3 scenarios. So also what is the energy performance level applied in the renovation. This is in this case, it's something very minimum, and in these other 2 scenarios, it's a so-called cost optimal level, which corresponds to that renovation practice we have in the KredEx scheme. And when indeed these renovation rates are different, so that the 3rd scenario uses quite a lot of renovation, so it's even 2.5% per year, which is a kind of a maximum, but maybe this 2nd scenario is more realistic, 1.5 for the apartment buildings and a bit less for other type of buildings. So when the demolition is kept constant in all scenarios, it's 0.3, and also new construction rates are kept constant, depending on the building category. And what is also changed is the application time for the nearly zero energy building requirements, which will start to apply for new buildings. So where before or in planned time or later, what are these three options. So, and this calculation will show that if renovation rates are low and energy performance level is not good, then basically no energy saving will be achieved. So it's calculated for 20 years, and after 20 years, building stock will use more energy in the first scenario compared to the starting point. And indeed, the reason is because building stock is all the time increasing with 1.5% of a new build. So all the time we are building new buildings, and total building stock is increasing, and it is not so easy to decrease the energy use of whole building stock. But this is possible when this better scenarios, like the second one, will be applied. It's already 8% saving in 20 years, or up to close to 20% in the third scenario, which is a kind of a technical economic maximum that can be achieved. So this is a second aspect. And third important aspect is indoor climate and all general technical conditions of a buildings, which is also very important. So in Estonian case, it's calculated that the cost for the government is close to 200 million euro per year because of bad indoor climate in buildings. So it means that energy cannot be saved on the cost of indoor climate, and it is very important to improve indoor climate and then have at the same time energy savings. This is also a very important starting point. So having this experience from first five-year KredEx period and all this information about economic effects, energy, indoor climate, so in Estonia it has been possible to develop the evidence-based policy and a new renovation grant system, which will be run for these years. And now it's 102 million euros, which are allocated for the KredEx to give these 15, 25 and 40% grants. And this new system puts stresses more the preparation work. Ventilation has higher importance and more strict requirement. More detailed building design documents are needed. Also more energy calculation for the verification purposes. And this third-party expert investigation for the design documentation has been launched in this period, and the use of technical consultants. Because for the housing associations, they typically do once in the lifetime such a large renovation projects, and they are not the construction professionals. They does not no need to know all these construction issues and how to run a tendering, design and construction process. It's not so easy indeed. For that purpose, these qualified technical consultants are used. They are supporting these housing associations. So requirements are with, as I already mentioned, Class C for the 40%, and some additional technical requirements for ventilation and installation. And this energy breakdown will be something like that to get this 40% grant. So delivered energy is close to 110, including all these heating and what you need for the ventilation, lighting and appliances in the building, so including all these user appliances, so it's a total energy use in the building. And when this energy performance class is calculated with primary energy factors, which are 1 if it is a gas heating, 0.9 if it is a district heating, so it will be a bit easier with a district heating, and a factor 2 for the electricity, and then you should be below 150. So that's the main requirement to get this grant. And then there are some additional requirements, so ventilation requirements, as the ventilation was a problem in the first period. Now it is specified how many liters per second in which room you need to have a ventilation, what can be a maximum noise level, so on. And in the case of that 25% renovation grant, heat recovery is not required, but it is recommended that intake air is preheated. So ventilation radiators are recommended, but you can go also with more simple intakes for this 25% of a grant. And this is the grant which is not very much in use. This 40% applies for majority of applications. This is the most popular because it's much more money and only small differences in the technical requirements. Basically, these, in the renovation project, when you are looking at from the street, you cannot say is it for 25 or 40, because external insulation and these are exactly the same in both cases, but indeed technical quality is somewhat different. And in this case, it is required to have a heat recovery ventilation, or it can be an exhaust air heat pump with ventilation radiators. So two basic ventilation solutions are accepted for the 30%. And when designers really need to design a new ventilation system and to apply these airflow rates for all rooms, specified how much apply, how much extract, and at the end they need to increase typically supply airflow rates in small apartments and extract airflow rates in large apartments in order to balance ventilation, and it typically ends up with air change rates around 0.6 or maximum 0.7 depending on the apartment. So 0.6, 0.7 air changes per hour are required with this system. And there are additional requirements for the thermal insulation. So U values are already quite low for 40% of a grant, also for the windows and roof, and there is a special requirements also for thermal bridges in the case of a 40% of a grant. So it means that natural ventilation will be not the case. If somebody would like to use a natural ventilation, it is not possible to apply for the renovation grant. These single room ventilation units will not be accepted because they are not as effective as should be. Thank you.
Thank you, Jarek. Do we have any public questions?
Hey, so basically I have been living in Mustamäe, the district of Tallinn, like almost 23 years. So, and I've been renovating my own apartment and some other apartments, and actually worked in constructions everywhere. It doesn't matter. So I know the problems we have to face when we renovate these Soviet period apartments. And you said you have like a 5-year plan. The 5-year plans are still like Soviet plans, but do you know how long people are gonna live these houses after KredEx has been renovating them?
I don't understand the question. It's indeed it's normal demographic situation will determine which people will live in these apartments.
I mean, like if you're renovating, KredEx is renovating the houses. How many years the house is gonna stay up?
How many years?
Yeah.
So this concrete will stay up forever, because after the renovation, all these structural parts are in the room temperature, so they are in the warm side because it is external renovation. And there are also reinforcements if needed, so this will stay forever. But we really, it's another question, how long time this facade will stay. If it is a plastering on the facade, so maybe replacement time will be 20 years or 15 years. So it depends indeed on the construction quality. But structural part is really preserved with this kind of a renovation, because all these load-bearing structures are in dry and warm environment after that renovation. So that's not the problem. They can stay for next 50 years, next 100 years, as much there is a need for these buildings. It's not a structural question. It is just how long this building will be needed in this location, in Mustamäe or in some other place. So real estate market will determine how long these buildings will stay, not the structural condition. And it's not complicated to make a new renovation after 15 or 20 years if you need to fix something.
Okay. Eesti keeles on selline ütlus, et õun hakkab mädanema südamest nagu sisust, aga see selleks. So actually another question is about capitalization, like are everybody in Estonia gonna move to Tallinn, and should we build like this kind of should Tallinn become like a crowded city, or we want to live in a city that's there are living people that everybody knows their neighbors and like that?
Parem ütlus on, et kala hakkab mädanema peast. Seda juhtub ka mõne puhul. But yes, this demographic situation, yes, this is a real process, but in Tallinn and in Tartu and in large cities, we really can renovate these buildings, and there are occupants for these buildings, and these cities are growing. So urbanization is going on, not only in Estonia, it's going on in Finland, it's going on in Sweden, in Norway, almost in everywhere. And in small cities, you have really a different situation. Buildings, some of the buildings are empty, and then it's a good idea to demolish these buildings and to concentrate existing occupants really in the city center. So this is a process what is happening in the small cities in Estonia. And actually, these renovation grants are not only grants we have in Estonia. We have also demolition grants for these small cities, and they apply these grants to demolish empty buildings. So that's maybe a best answer for your question. So it really depends on the city, and construction sector is not making a demographic policy. We just renovate or we build new buildings as much as needed, or we demolish the buildings. So this is basically not our business. But we see that the trends are similar in all over the world. Urbanization process has not yet stopped. It's ongoing also in all our Nordic countries. So the Tallinn will grow, and I will see it's a positive. It's a more economy, more business, better life standard for you, and so on.
Sorry, but I didn't understand. Who are you saying? Who is the occupant? Occupation.
Perhaps I will ask the anonymous questions in between. There is a question. If a community decided to renovate, but the end result didn't end up as the energy class that they applied for, do they have to pay the whole grant back?
No, no. There is a requirement that after 1 full year of operation, they will need to provide a new energy performance certificate based on the metered energy use. But this is for statistical purposes. KredEx will just follow up how successful the system is. But if they do not achieve the target, no need to pay back. So if it will be general case, then the KredEx will make some changes in the system. But this is just, the purpose is to collect the data. So it's, as I told it's a kind of evidence-based grant system, and so this collecting data is very important to get also this evidence from actual energy saving.
I will ask one more question. How complicated is it to renovate a 50-year-old Soviet building to, for example, energy class C?
Energy class C is a common practice what is done. It's a 40% grant. It's the most popular grant they apply, so almost 100% of these buildings will be renovated to energy class C because it's so financially so attractive for these housing associations to go with that grant.
Thank you, Jarek. Now we would like to thank you on behalf of the BuildIT team.